Now we want to look at one of the most useful theorems that you'll encounter, the Pythagorean Theorem. And it deals with right triangles. And in fact, if you have a right triangle, so if I draw a right triangle and I take note of the side lengths, so maybe we have A, B, C, I make the hypotenuse C. The Pythagorean theorem tells us this, that if you take the sum of the squares of the non-hypotenuse sides, the legs, it equals the square of the hypotenuse. Okay? So a squared plus b squared equals c squared. Now, we could solve for any side of the right triangle given the other two sides. So, for example, if we know the hypotenuse and we want to find side A, we could say, well, a squared is equal to c squared minus b squared. Or, we could say, well, b squared is equal to c squared minus a squared. The thing is, the hypotenuse is the side opposite the right triangle, and the Pythagorean theorem tells us if we know two of the sides, we can get the third. So let's suppose that we know that A is equal to 3, and let's suppose B is equal to 4, and we want to find the hypotenuse. Well, here we go. We've got c squared is equal to 3 squared plus 4 squared, and that is, that is equal to 9 plus 16. So we've got c squared is equal to 9 plus 16, which is 25. And that means c is equal to 5 if we take the square root on both sides. So this is what Pythagorean theorem gives us the ability to do. Now, I want to show you why, one of the ways that we can determine that the Pythagorean theorem works. Let's think about this rectangle, or this square that I've drawn over here. See, I've just drawn a square here. And inside the square, I have drawn some lines. I've drawn, 2 units here. I've drawn a line over to where I have 2 units here. I've drawn another line, and another line, and another line. So I've drawn these lines, and I noticed that they made 4 triangles. 4 triangles that look like this right here. Okay? So all I did was, notice I just went to where I have 2 units here, and I connected those. 2 units here, and I connected those. 2 units here, connected this one. See? And then before you know it, I've got this square. Okay, now notice that the area of any of those triangles, any one of the triangles, is just 1/2 base times height. Okay? 1/2 the base times the height. So if I want to talk about the area of these 4 triangles, I could just say, well, 4 times that, and I get 2AB. So if we just want to talk about the area of those triangles, it's 2AB. Now, let's suppose I want all the area that's inside this thing. Well, I've got the 4 triangles, that's 2AB, but then I've got the c squared, the area of the square on the inside. So the area of the whole thing is 2AB plus c squared. Okay, yeah, that's it. Now, another way we could do that is we could say, well, I've got A plus B, that's the width, and then I've got A plus B here, that's the height, width and the length. So I could talk about, well, the area is A plus B times A plus B, which, if we multiply that out, we get A squared plus AB plus another AB. Just doing some old-fashioned algebra here. And we get A squared plus 2AB plus B squared. So dig what we have now. We found earlier that the area is 2AB plus C squared. And now this new way, we're saying the area is A squared plus 2AB plus B squared. Well, the two AB's cancel, and we get c squared is equal to a squared plus b squared. Yeah. So if you do have a right triangle, the hypotenuse squared is equal to the sum of the squares of the other two sides. Yeah. That's if you have a right triangle. Now, let's suppose that you have a situation where c squared does equal a squared plus b squared for just some triangle. And you're wondering, does that mean that that triangle is a right triangle? Okay. In other words, the longest side squared equals the sum of the squares of the other two sides. Well, we already know it works for a right triangle. Here we've got c squared equals a squared plus b squared for this triangle right here. Now look at this next one over here. This is not a right triangle. This is an obtuse triangle. It's got an angle bigger than 90 in it. Suppose that a squared plus b squared does equal the longest side squared. Suppose that's true. Let's just suppose. So this is an example of where I'm going to do a proof by contradiction. Let's just, for the sake of argument, suppose that a squared plus b squared does equal c squared. Now I'm going to do this. I'm going to drop a altitude here. And I'll call the length of this little new triangle here x, and the height I'll call y. Now we know from this that x squared plus y squared is equal to a squared, because for this little right triangle here that we formed, that's the truth, okay? So a squared equals x squared plus y squared. Now, we also have a big triangle here now. Look at this. This is a big right triangle, and we know that this side over here, which is b plus x, we know that b plus x squared plus y squared has got to equal c squared, because it's a right triangle. That for sure is true. Now let me multiply out this b plus x squared. Well, I get b plus x times b plus x plus y squared, and that's got to equal c squared. So let's see, if we multiply this, we get b squared plus bx plus another bx plus x squared, and then plus y squared equals c squared. Okay, now let's see if we can add things together. We've got b squared plus 2bx plus x squared plus y squared. Yeah, like that. Now, remember, x squared plus y squared equals a squared. So here's what we've got. B squared plus 2bx plus a squared is equal to c squared. Ah. Well, that doesn't work out, right? It's not a squared plus b squared equals c squared. It's a squared plus b squared plus 2bx equals c squared. So it looks like, in this case, c squared is actually bigger than a squared plus b squared. Yeah. So whenever that happens, whenever the longest side squared is bigger than the sum of the squares of the other two sides, you have yourself an obtuse triangle. If it happens to be less than, if c squared is less than a squared plus b squared, then you have an acute triangle. So we know this is an obtuse. Okay, so this gives you an obtuse. If c squared is less than a squared plus b squared, then you know that you have an acute. Now remember, c is the longest side. Yeah, exactly. So we could say, well, what about this? What about, let's determine if this 6, 8, and 10. Let's suppose if those three sides will give you a right triangle. Well, it will give me a right triangle if this is true. If 10 squared equals 6 squared plus 8 squared. Well, let's see. 10 squared is 100. 6 squared is 36. And 8 squared is 64. So we've got 100 on this side and 100 on this side. Ooh, yes. This is a right triangle because the longest side squared equals the sum of the squares of the other two sides. Okay. Now, what if we have this? What if we have 6, 8, and 11? Okay, so we have 11 squared, which is 121. Okay. Now, let's do 6 squared plus 8 squared. Okay, so that's going to be 36 plus 64, which is 100. And now we've got 121, which is 11 squared. And over here we've got 100. Well, 121 is bigger than 100. Okay. So if that happens, then you know that you have an obtuse triangle here. Yeah, so Pythagorean theorem goes both ways. If you have a right triangle, then a squared plus b squared equals c squared. If a squared plus b squared equals c squared, if you have that, then you know that you're dealing with a right triangle.